Hello, welcome to Brown Dog Gadgets Live. I am Amanda, the Education Outreach Coordinator here at Brown Dog Gadgets, and behind the camera I've got Pete.
Right here.
Today we are going to jump into a little bit more MicroBit University. Of course I grabbed the green one, so you know it blends in with the background, our green screen. But before we jump into that, I just want to remind you, if you have not followed us on our social media platforms, please do so. You can find us on Facebook, Instagram, Twitter, X, and YouTube. Also, all the guides and code and descriptions of how to do the projects that we're talking about here today can be found on browndoggadgets.com, along with all of our products and project templates. If you have any questions, you can ask while we're streaming, leave a comment, just say hi, but then feel free to email us afterwards at help@browndoggadgets.com. And if you would like a free 40-hour professional development this summer with us on circuitry and robotics with Lego and MicroBit, you can sign up here. You do need to be a U.S. public or charter educator to qualify, and it is for 4th through 12th grade educators, and we send you a big old box of stuff, and you build along with us. Sure, not a joke, but I'll take it.
It's my new one.
All right, wonderful. All right, we're going to jump into our MicroBit University. We are on Chapter 6, 4 buttons. All right. I've got my nice plain base plate here, got a MicroBit, we've got our bit board. So if you haven't watched any of the other ones, I would highly suggest going back and checking those out, because we talk about how to use the bit board and the MicroBit together, how they connect to Lego. But today we are hooking up 4 buttons with our LED to our bit board, and then of course with our MicroBit.
Yeah.
I'm gonna run a little bit of tape. Now, honestly, I'd probably be weird and like have them right next to each other, just so my tape paths could be perfectly straight.
That's next week.
But you can also have them spread out if
you
need space for your fingers.
Well, I do like the fact, my fingers are so large, so I do like the fact they have a little more space. For next week's, it's a little more crowded, so we do shove them all right together. But we also want to show how you can do tape paths, right angle turns.
Did you fit all for next week on one base plate?
4 and 4.
Oh man, 4 LEDs and 4 push buttons.
Just barely.
Not the big ones though.
No.
I do like these.
Those are nice. Yeah.
Have a nice clicking sound to them.
Definitely.
These have a little bit of one, but that's
okay.
All right, I'm just going to rig up just one pathway just to show you how it's done. When you make the pathways for our Crazy Circuits parts, we use our our 1/8 inch maker tape. So if you've seen some of other lives, we use 1/4 inch maker tape for paper circuit projects. This is 1/8 inch maker tape. It is thinner, so it fits on the studs better.
Mm-hmm.
All right, so the first pathway would come from ground, and I'm going to stick it down to the stud that I want to start at, and then use the actual bit board to push it down in place.
Good idea.
So it makes a nice solid connection. All right. And then you'll notice on here we have the LED connected to pin 1.
Now, if you don't have a bit board, well, you should get one. I don't know. You can't do any of this without one. So,
you can do the very first chapter.
How are you going to do that?
With alligator clips.
No, you don't.
Technically you can.
Okay. All right. Technically.
But that's about it.
Okay, I'll go with that.
Yep. They really do open up the possibilities of the MicroBit. And I think I made that path a little too short. So all I'm going to do is cut a little bit more before I completely lose the tape path.
I wouldn't want to try to connect 4 buttons and an LED with alligator clips. This is not.
Well, you wouldn't be able to connect to all those pins.
That's the other problem, yeah.
It helps us access all of those pins.
You could do it if you had the bit board, but you don't want to connect all those alligator clips.
No, you really don't.
Bad idea.
All right. Then, so this pathway will actually lead from the positive side of the LED to pin 1. And then we need a pathway that comes out of the negative side of the LED that leads to ground.
It's the beauty of the tape.
So true.
Wires.
There we go. So that is just wiring up an LED, and then you've got to wire up all those push buttons, which will also then connect to ground.
Ooh, I see you did a 90 rotation on your LED there. It still works.
I
for your
just picked it up. I just made sure it was yeah.
It works though. It works out.
It does, absolutely. You just want to make sure that the colored holes or the black holes for the LEDs are leading to the pin, and then the white hole, so the side that has white around it, is ground, and that needs to lead to your ground on the bit board.
That's the nice thing too about doing that sort of diagonal tape, like on each corner from each other, is that you can rotate it one way and it'll still work.
Yeah, absolutely.
Yeah.
All right, so I'm not going to sit here and make you watch me tape up all 4 pins or all 4 of the push buttons, because
we already did it.
That would be kind of boring to watch me do that.
Someone else
it's already
can do
done.
It. If you have to do it, just pause the video. Can they pause it? It's live.
I don't think they can pause it when it's live.
They can come back. Here's what you should do: watch the whole video, and then do your tape, and then go rewatch.
Or
yes.
Or
yeah.
Pull up browndoggadgets.com. Sorry, learn.browndoggadgets.com and click on or search MicroBit University and jump into chapter 6, and you can have your own little diagram to look at while we're going.
And if you do that, know that after tomorrow, we'll embed this video into that guide as well.
Absolutely.
We haven't done it yet because the video isn't done yet. We're still making it.
Perfect. All right.
Okay, cool.
So we've got 4 push buttons today and an LED. I'm going to add some power to our bit board, and it's not going to do anything without the MicroBit.
Right.
All right, so the first one we are doing is 4-button fade. I know, it's a magic cake, isn't it?
Right.
That's right.
Okay.
4-button fade. All right. What'd I do? I pulled the correct one.
Did I load the code?
There we go.
Oh, there you go.
Just had to mess around with things a little bit.
Okay.
So Pete, talk to us about what's happening with 4-button fade.
So, while you see it did sort of pulsate. It's not really doing that. It has to do with a camera weirdness with PWM or pulse width modulation. But basically, the LED is dimming down. So, do we want to look at the code and walk through
I think that would be great.
You pressed all the buttons.
I pressed all the buttons. I didn't press them in order.
See if I can do this. Okay. Whoa, hold on. Let's get that code. Hey, all right. Here we go. Chapter 6, 4 buttons.
Awesome.
And you've got your 4 buttons fade in there. That's everything we just did. Let's look at that code, and we'll just look at it here. Okay, so as usual, we only did 2 buttons last week, right?
Correct.
Okay, so for 4, we're setting up those 4 pins for those 4 buttons so that the pins are pulled up. And that's sort of electrically what it means is we're applying a voltage to them. So
quick question before we move on. Is there any reason that you picked pins 4, 5, 6, and 7?
Oh.
Or is it just because it laid out nicely on the base plate?
Slightly. So I wanted to do them in a row.
Okay.
I could have used 0, 1, 2, 3, or even 1, 2, 3, 4 for the buttons. But the issue is, if I end up using 5 for one of the LEDs, you're going to get some weird, funky stuff. And I'll explain why. We're using pin 4, 5, 6, 7 for the buttons. Pin 5, so if you can press, if you press that A button on the MicroBit, you'll see it's doing the same thing that you would do if you pressed that second button on pin 5, because pin 5 is actually connected to button A. Button B is connected to pin 11 on the back of the bitboard. So we always recommend try to avoid connecting an LED to pin 5 or 11. We should do a thing showing what happens. Basically, it's gonna light up. It's gonna be a little dim though, I think, but it'll light up. And the issue is because you know how we do this pull pin to up. I think those pins are already like floating values, so they're not 0 voltage. They're not maybe all the way up, but they have some value to them, some voltage applied to them. So it does weird, funky things with LEDs. So we try to avoid connecting LEDs to 5 or 11. So in this case, I wanted those LEDs on the lower pins, lower than 5, and the buttons on 5 and up or whatever. So
awesome.
That's our layout. So hopefully that makes sense.
It does.
Okay, good. Of course, again, we turn off the built-in LED matrix on the front of the MicroBit. And the reason we do that is that uses a whole bunch of the pins. So I think if you look at that giant MicroBit you have there, you see 0 and 1 and 2. So those pins you can use for anything, anytime. But a bunch of the other pins, probably 4 and 6 and 7, those are used by that LED matrix. So if you have some sort of animation playing like you have there, and you also want to use those pins for buttons or other things, it won't work because they're collision, they're already in use. So, and we'll get into that as we get deeper into this whole MicroBit University thing. So that said, let's move on.
Yep.
So we've turned off the built-in LED matrix. We've got our pull pins set for our buttons. Over in our forever loop here, we're doing an if-else loop with 4 different things. So we're checking the status of the pins that those buttons are on. So pin 4, pin 5, 6, and 7. And since we pulled those pins up or set them to high or 1, which is on, 0 being off or down, this forever loop goes around and around, and it's going to look for any pin that is 0. And it gets 0, it gets pulled to 0, pulled down to 0 when you press on it. Because what happens is the voltage that's flowing through that pin, you're making that connection, the voltage flows through to ground, and that pin is then low or 0, and that's what happens. So we're basically just calling the same function, but with a different value each time. So if we look at that function, which I call brightness x, which is over here, what it's going to do is send that value over. So for the first one, it's 256. It sends it over here, and it's gonna get captured in this thing called num, which stands for number. We're gonna set our pin 1, which has the LED, to num, which in this case is 256, and would be a different value depending on which button you press. It's gonna wait 1 second, or 1,000 milliseconds, and then it's gonna set the brightness to that value, whichever one we passed on when we called the function. And now it's gonna repeat that number of times. So for this, it's going to repeat 256 times. And what it's going to do is keep lowering that value by just 1, or -1 as it were. And it's going to wait 0.5 milliseconds, which is not much. And it's going to keep looping around. Every time it loops around in that repeat, it's going to subtract 1. So it's going to go from 256 all the way down to 0. It's going to take 256 steps to do that with 0.5 milliseconds per step. And eventually it'll get to 0. And it'll probably go past 0 because we haven't told it to stop, right? It's going to keep going. But you'll just see it as the LED off. So, for all we know, that value is in the negative thousands by now.
Yeah, but you have it repeating the certain number of times, right?
Oh, that's right. Yeah, so it does break out of that eventually.
Right.
Yeah, sorry. You're right. For this one, it does do that.
Aha, I caught
I'm
that.
thinking of, yes.
I feel like you're quizzing me.
Oh yeah, that's totally
what
what I'm doing. It's because I've written so much code and so much different code in the last few weeks that I'm trying to remember what everything does.
Yeah, that's all right.
Because like this, when we look at the next one, you'll see we take this one just a little bit further. We add a little more to it, a little more math. So, but that's what happens. So we set up our pins. We're checking for those button presses. If a button is pressed, we call our function. We pass in a parameter. And we do our little fading. That's it.
So each pin just starts at a different brightness value.
Mm-hmm. Yeah, depending on what you give. So, and it's the same, we're doing the same amount of pause between steps. So if you press that fourth one, it should take quite a bit more time to step down because it's starting brighter.
Right.
If you press that first one, it's already starting at like a quarter brightness. So, but it's basically going the same rate. It's just they're starting at a different brightness, as it were.
Nice.
Cool.
Awesome. All right. And then the other one we have for chapter 6 is 4-button fade down.
Yeah, let's find that one. 4 buttons fade down. Yes. Same buttons. Same everything except the code. So let's look at the code. Okay, so this one is somewhat the same. The start is the same. The forever is pretty similar. We're still checking for those button presses. In our function, we're actually sending 2 parameters. So we're sending that brightness value again, but we're also sending a second value, which I think, what am I calling that one? Oh, it's our step value. So X for brightness, S for step value. So we send 2 things. So over here, again, we've got our turn on the LED at whatever brightness, and you can see we're passing in num and num2. And it just, when you create a function in MakeCode, it'll just name these whatever, num2, num3. As you add more parameters to your function, it'll just name them that. So, okay, so it turns it on. It waits 1 second, 1,000 milliseconds, and then it does a bit of sort of variable assignment and some math. So instead of just using num, we're going to say set our start value to num. And as we work with more variables, we're basically assigning them to named variables so we can keep them straight. Because if you've got num2, num3, num4, and you're down here using them, it's like, I got to remember which is which. So we give them nice names. And then we're setting the value to start value. So now when this starts, start value and the value have the same value to them. But as we go through the loop, one of them will change. And finally, we're going to set our loop x, which stands for loop x number of times, to our start value divided by the absolute value of the step value. Because our step value, remember, is a negative number. So we want to divide, but we want to divide by the positive version of that number. So either 5 or 10 versus negative 5, whatever. Because you get a very different value. I'm not good at math, but I believe you'll get a quite different value if you divide by a negative number. So, okay, so now we've got our loop x is how many times we're going to loop. And as we loop through here, we've got the value is what we're using instead of num, which we assigned a start value. So we're going to change the brightness of that pin, and then we're going to change the value by that step value. So if you press that first button, it's going to lower it 5, basically. If you press that fourth button, it's going to lower it 50. And it's going to loop around doing that. And this time we're pausing 10 milliseconds. Now, you might be saying, I wish I could change how long we pause. Well, you could. So would you like to guess how you would do that, Amanda? Why don't you figure it out?
Just change the number in the pause block?
You could do that, or in your function, you could add another parameter and then pass it in when you call that function. So you'd have num3, and down here you could say pause num3, or you might assign it to a name like pause value or something.
Okay, yeah.
So anything you see in here hard-coded, like this here where we wait 1 second, that could be a parameter as well that you would pass in.
I definitely thought you were going to go over my head with it, and I understood it.
Yeah, and basically, like this is how software, this is how it works. These functions, they don't always have a ton of parameters. Often there's different functions that are specific to certain things. But the idea is, when you're writing software, is to make it generic enough so that you can do a whole bunch of things with it. So, at first we could only adjust one thing. Now we can adjust two things. We could add two more variables and adjust two more things. With more complex software, sometimes those parameters are optional. So instead of passing in 6 different values, you may only need to pass in 2 or 3, and the default values would be set by a function, and those are okay to go with. So I don't want to get too deep into software philosophy, but and then eventually that's how things like libraries are created. Libraries are basically a collection of functions. So every time you're seeing what we did here, I mostly rewrote a lot of these functions, but the idea is you would write a function once and you can kind of use it over and over again, and you don't have to keep rewriting your code. There's this thing called DRY in software development, where DRY stands for don't repeat yourself. So once you've written some code to do something, use it again and again.
Right.
You shouldn't have to rewrite it.
Makes sense. I think we also had a comment at some point.
Ooh, let me see. Oh, Mike's here. Let's see.
I'm guessing it's Mike. I appreciate you, Mike.
Oh, interesting. Let's see if we can read this here. I'm just going to cause variable value instead of saying, yeah, MakeCode does a pretty good job of keeping it simple, but stuff can get really advanced as far as variables, how they get assigned or copied to other things, how they reference other things in code. Luckily, I think MakeCode is made sort of for beginners, basically. And it kind of makes those logical choices, I think, that make it pretty simple.
Nice.
That's my thought on it. Yeah.
Awesome. It definitely looks like it's actually pulsing on camera right now.
Oh, yeah. That'll happen.
It's on. It's dim right now.
Yeah, that's the trick of it's hard to get the frame rate just right, especially for this streaming stuff. And I think is that all we have for
awesome.
4 buttons? Yeah.
Yeah, because then next week when we do 4 buttons and 4 LEDs, is that going to be in Chapter 6 as well?
No, we'll move on to 7, because
Chapter 7.
I think we've tried to make it so a chapter is everything taped up the same, and then just the code changes.
Yeah, I like that.
But I feel like we've done enough with buttons that we'll jump into 4 and show you how 4 works, but we don't need a million examples of do it with 4. We will get probably multiple buttons going again when we get into other components. But for sort of the LED button thing, this is probably pretty good.
Awesome.
Yeah.
That was interesting. It definitely is starting to go over my head, but I'm learning more every time.
Well, you know what? You're here to ask questions too. If there's anything
absolutely.
that is confusing, because I'll just go on.
Yep.
So yeah, if there's anything where you're not getting it, just let me know, and I do my best to explain it.
Absolutely.
So that's simple.
Awesome. So that was Chapter 6 of MicroBit University. We are going to be continuing MicroBit University on Thursday still. Yeah. So next week, Tuesday, we'll be back on paper circuits with our Easter Bunny glasses, I believe.
Yes.
Then Wednesday, we're going to check out the new design to our solar bugs. They have legs. They're a little bit larger. They're so much fun. I am really enjoying the butterfly specifically. I have to color the stag beetle for you guys for next week still, though.
Okay.
We'll see how that one goes. It needs to be metallic in some way.
Ooh. Yeah, you could get pretty fancy with some of yours, I feel like.
Absolutely.
Definitely.
And then, next Thursday we will do 4 push buttons and 4 LEDs for MicroBit University.
Yeah, lots of tape on that one.
Absolutely. I will not be taping all of that on camera. No.
I've already done it.
Yep. If you have not done so already, please make sure you follow us on our social media platforms. You can find us on Facebook, Instagram, Twitter or X, and YouTube. Remember that the guides for all the MicroBit University stuff, as well as all of our projects and products, can be found at browndoggadgets.com. If you have any questions after this live stream, you can email us at help@browndoggadgets.com. And if you would like to sign up for a fun 40-hour workshop this summer with us, you can do that at, there we go.
Who can sign up?
p2url.com/pathfinders.
Can I sign up?
No, you'll be here anyway.
Public school or charter school teachers? Is that
Correct.
Okay.
Public and charter school educators.
Educators, yes.
Librarians. And librarians.
Yeah. Librarians are educators.
I can take in a couple librarians. I can't. Mm-hmm. It can't all be librarians, unfortunately. Okay. 10%.
How many spots do we have left?
Right now, we have 17 spots available.
Ooh, okay, great.
Till we hit our capacity, our hopefully temporary capacity.
Yeah.
Yeah.
Okay.
So we would love to have you. You can sign up and join us this June for 40 hours of an awesome PD. Nice. Yeah. Perfect. That's all I've got for you today. Thanks for joining us. Have a great weekend, and we'll see you next week.
Bye-bye.
Bye.